a system for driving piles into hard stony ground or through underground obstacles like concrete, using rotary press-in and tubular piles with cutting bits at the pile toe. That's the Gyropress method. The press-in method ranges from standard press-in using static load only to combined methods employing a water jet or an auger, allowing work to be executed in various types of ground. But in the past, prefabricated piles could not be installed directly through hard ground, reinforced concrete and other obstructions, and these had to be cleared away or substituted before inserting piles. With the Gyropress method, it is possible to install piles directly into the ground where piling work has been difficult with conventional methods. The Gyropress method started with the development of the gyropiler in 1981. Giken Türkiye was the first company in the world to take this groundbreaking step of adding a rotary mechanism to the press-in principle. A great number of field tests were carried out, and in 2003, Giken created a whole new area in the construction industry with the commercial introduction of the Gyropress method. At present, the Gyropress method is registered with the Japanese Ministry of Land, Infrastructure, Transport and Tourism, and is attracting interest as a method capable of solving the problems of conventional approaches. The system is steadily building a record of successful implementation in various different infrastructure projects. The Gyropress method is used principally to build continuous tubular pile walls. The gyropiler guarantees a large reaction force by gripping completed piles. By adding a rotational force to the conventional press-in force acting in the vertical direction, the skin friction is reduced. In addition to this, only the cross-section of the pile is cut by the bits on the pile toe, which means soil displacement is restricted and the effects on the adjacent ground can be kept to a minimum. The tubular piles with toe bits have been developed through verification tests envisaging various ground conditions and are designed to ensure quality and improve work efficiency and cost performance. The standard machine layout is simple and compact, including the gyropiler, power unit, tubular piles with toe bits and auxiliary crane. In the initial press-in phase, a special reaction stand is installed. The gyropiler is assembled on top of this stand. The first pile is stood in position and a rotary cutting and press-in operation is started. The gyropiler uses a self-walking action to proceed with the second and subsequent piles, gripping the completed piles to increase the reaction force. When all of the clamps are gripping reaction piles, the reaction stand is withdrawn and the initial press-in phase is completed. When using the gyropiler in a non-staging method, the same piler and power unit are used as in the standard method, along with a clamp crane for pitching the piles and a pile runner for conveying the piles from the work base. These devices carry out their work on top of the completed piles, conveying the piles, pitching the piles and executing press-in work. All of these steps can be carried out without the need for any temporary works, and piling is possible in various restricted conditions, such as narrow access sites where machinery cannot enter, or on slopes or over water where temporary platforms are needed. The tubular piles installed with the Gyropress method make it possible to select an economical structure based on the pile diameter and pile arrangement, the auxiliary use of raking piles, and so on. The piles are confirmed to have a horizontal bearing capacity equal to or greater than the theoretical value. In this way, the Gyropress method is able to reduce costs and work times while limiting environmental impact under many different operating conditions. There are various models of the gyropiler besides the standard machine for general use. The Gyro Clear Piler for use in sites with limited overhead clearance, a laterally inclining gyropiler which is capable of installing raking piles, and a gyropiler fitted with a load mechanism for checking the vertical bearing capacity of the piles during execution. Also under development, there is a gyropiler which is capable of handling various sizes, from 500mm piles to 1500mm steel tubes, and can be adapted to tubular piles of even greater diameter. Environmentally safe biodegradable oils are used in the hydraulic system of the power unit, and the engine specifications require exhaust gas control in compliance with the off-road law, as well as ultra-low noise emissions and low vibration. The Gyropress method has already produced results in various projects. A riverbank revetment project not accessible to large heavy equipment like a crane barge. Road widening directly beside a hospital ward, where environmental concerns were especially important. Waterway repair work passing through existing concrete embankments with limited overhead clearance. Bridge substructure work for reinforcing earthquake-damaged pillar foundations. A harbour project for bracing an existing tubular sheet pile revetment with raking piles, and a road improvement work in a quiet residential neighbourhood. During this operation, the behaviour, noise, vibration and other characteristics of the pressing machine have been monitored in real time with the EMOS environmental monitoring system, and work has been carried out safely and reliably in a restricted work area. In this way, the Gyropress method overcomes difficult working conditions and enables piles to be installed into rock, hard stony ground or reinforced concrete. Many infrastructure projects which have been difficult with conventional methods, revetments and retaining walls where the existing structure is to be left in place, protective screens for containing pollution, continuous walls built into hard rock and so on, can now be implemented safely and reliably.